floating rocks. The pictures show a piece of pumice, a type of volcanic rock. The first picture shows the structure of the rock. Looks like it's got lots of little holes in there. The second picture shows the pumice floating in a glass of water. This is actually true. I've seen this. The rock will continue to float for hours. What type of holes should a rock have to allow water to move through it? Should the holes be connected? Should they not be connected? Or no holes at all? You can check your answer. What is the likely porosity and permeability of pumice? Well, let's look here. It looks like it has a lot of holes. So it's probably got high porosity. So it's probably one of these two answers. And if you explain your answer, make sure you talk about permeability. Is the water passing through Answer that question. Is the water passing through this piece of pumice? Are those pores connected? And then explain how certain you are about your claim. Have you seen pumice in real life? Do you have any personal experience? What do you see in the picture? So you could say something about the rock is floating. The density of the rock must be less than water, otherwise it wouldn't float. If the density of the rock is low, it must have a lot of air in it. The rock must have lots of air in it. And really how pumice forms, you could go look it up on the internet, or I can just tell you. Pumice is formed when gas bubbles are trapped in lava and then it hardens. So it's kind of like the rock version of a sponge. If you can imagine a sponge, a nice squishy sponge with lots of holes in it, just turned to rock, that's what pumice would be. And you can submit your own answers and see what your ratings are. And if they're low, like they were in the last activity, in activity 4, make sure you add more evidence. So now it's our turn to build an aquifer. We're going to look at where does water accumulate. The model below is empty because you'll be designing your own set of sediment and rock layers. We're going to design a model that has at least 3 different layers and has a place where water pools in the middle. If water is going to pool, we should think about having a layer that's has very low permeability. We're going to use the Add Layers as a drop-down tool to select the sediment. So right here, you get to select what kind of rock. This is highly permeable. This is not permeable. We're going to draw on the model where you want that sediment layer to be. The cursor is going to turn into a pencil icon. We're going to repeat for additional sediment layers. Remember, you need at least 3. If you want to remove a layer, click Remove button and then the layer you want to remove. Click the play button to start the model. It'll rain and we can see how our aquifer functions. So we've got a couple layers here of impermeable rock. I've added those. I'm going to start adding some more permeable rock, but I'm going to leave kind of a spot in the middle so water kind of builds up. The water table gets interrupted in the middle. So we're going to make like a lake or a riverbed in the middle here. Now when it rains, I'm going to put some, I'm going to pretend that this brown stuff is soil and kind of put that on top and just think that there are plants on top of that soil. So now I'm going to make it rain. And you can see that the rain just kind of runs off right into the bottom of my impermeable layer here and starts to fill up and make a little lake or a river. Add notes to explain why water moved as it did. Take a snapshot. So I'm going to pick the pen, pick a color, and I'm going to point to my very permeable layers here with the yellow arrow. And I'm going to explain that the permeable rock let the water flow into the area over the impermeable or not permeable rock. The water pooled because it cannot flow through the bedrock material because it has no permeability. How did you get the water to pool in the middle? Think of the shapes of the layers and the properties of each layer. Well, if we think about, if you know or understand the water table would be about right in here. And the water table is just interrupted by this chunk of land that we took out. And so lakes or rivers are basically just the water table coming to the surface because the surface has changed its shape. Water pools in the middle because there is a layer of impermeable rock beneath it. Otherwise, it would just run right through. We see the groundwater as surface water because the surface dips below the water table. Just to be clear about what the water table is, let's draw the water table here. It's the top of the saturated part of the aquifer, of the sediment here. So water is filling up all the pores in the sediment here. And this level right here, where the water is going up to, is the water table. It's where you would hit water if you were digging or drilling a well. And you can see that the surface in the middle dips below the water table, and that becomes the surface of a lake or a river. Let's just call it a lake because we're in Minnesota and we have lots of lakes here. Lakes can form other ways, but this is one of the ways lakes form. It's just the water table is interrupted because the surface changes. So let's go to page 7. An aquifer is a layer of rock or sediment below the Earth's surface that holds groundwater, preventing it from seeping deeper underground. Use the model to explore why some aquifers are better sources than others. Add water to different layers by clicking Add Water. Draw in the model where you want water to appear. Try to pump water out of the layers by drilling wells to see the rate at which water can be pumped out. Click the Add Well button and then click the surface to drill a well. Release the mouse button when your well is as long as you want it. You can remove wells by clicking on the Remove button and then select Remove Well option and clicking on the well you want to remove. Determine which aquifer is best for sustaining water flow for a well. A steady stream of water from the well indicates that the aquifer is usable for human water use. If the water comes out only sporadically, that's water comes out, then it doesn't, then it comes out, then it doesn't, it's not very useful for maintaining a steady supply. Imagine that your shower only worked some days, or water would only come out of your kitchen sink, every Tuesday. That wouldn't be very convenient. So let's add some water in different places in this aquifer and see where it goes and where it stays so we can pump it out. So we can see that water is kind of pooling here and here and here. So we could try to drill wells in those places. So let's add a well. The first place I want to drill is right here. There's not very much drilling, or there's a low distance to the water here. So I'm going to start drilling here because this would be a low cost place to drill a well. I'm going to drill one up here just because this is the least distance to water. That would be the least expensive well to drill. It costs, the deeper your well, the more expensive it is. It's just a practical way to think about wells. And then I'll try here. I think we want to add a little bit more water before we try to start pumping. Okay, so we can see each of our wells is doing pretty well right now. They each have different colors. The blue line represents this well in the middle. The black line represents this well over here on the right. And the pink line represents this well over here on the left. It looks like that one has a pretty continuous supply of water. The black one is doing okay. And number 2 is kind of gone down very quickly. This pink line, well number 2, is kind of going up and then down and then up. I wonder what it will continue to do. Ooh, look at number 2. It's kind of it's kind of making a zigzag shape. That's probably not a great well, especially if you have it for an entire city. Number 1 seems pretty well, doing pretty well, pun intended. It's doing good. The water is pretty continuous. It's starting to kind of level out here, and we're getting a good amount of water that's continuous. We're always getting the same amount of water. That's a good well. The pink one, the well over here, goes up and down and up and down and up and down. And that's not great for a well because you're not always sure how much water you're going to have. Like this well, if it was a personal household well, you might not have enough water to take a shower every day or do your laundry. You might only have enough to wash your dishes and drink and cook. The number 3 well here, which is the black line, is doing okay. It's probably an okay place to build a well. Let's stop adding water here before we flood the whole landscape. Take a snapshot of the model showing an aquifer that supplied a steady supply of water. Well, we kind of flooded this aquifer a little bit, but we can take a snapshot anyways. Maybe this is a spring snowmelt. So I'm going to circle this one in the middle. And say, well number 1 provided the steadiest supply of water. The most reliable or continuous supply of water because the line on the graph is level after the first 2 years. I'm going to look at the line on the graph here, and it's about producing about 250. I'm not sure what the units here is, but well, 1 produces about 250 units of water from, let's say, year 3 to year 6. I'm looking here on the graph. That's about year 3 because it's between year 2 and year 4. And here's year 6. Your graph won't look exactly like mine, but you can do something similar. Make sure you talk about the graph and the numbers on the graph and the lines on the graph to support your statement, your claim. What properties of the rock or sediment make for an aquifer that produces a steady supply of water? Well, we need kind of something on the bottom to hold the water. Just like this jar is holding, if I pour water into it, the glass on the bottom holds the water from going through. Or this gravel will let the water go through, but then the glass is an impermeable layer and it won't let the water through. Let's actually do that here. So I have a jar of marbles here, and the jar they're in is glass, which is not permeable. We can see that if we pour the water in, it doesn't go through the bottom of the marbles. The impermeable or not permeable glass jar is holding the water, and the water is sitting between the marbles or the particles in this case, the soil or sediment particles. So we see how we need something kind of on the bottom of our aquifer to hold the water in place so it doesn't just run right through. If we didn't have the glass here, the jar, the water would just keep going through the marbles and run right out. So your answer for question 21 should include the words permeable, not permeable, and rainfall. Like, where does the rainfall go? Does it go through the permeable rock and then sit on top of the impermeable rock? Think about that for your answer. When you're done, let's go to page 8. Where should you drill the well? The picture shows a cross-section of earth. The pink layer is highly permeable, but only provides useful amounts of water if you drill in the right places. Why do you need to drill into the bottom of the pink layer to get a steady supply of water? Well, they're saying you need to drill all the way down here to get some water. What happens? Let's pretend the pink layer is our jar of marbles. What happens when you put water in the pink layer? It just keeps running right down until it hits something that it can't go through. It hits an impermeable or not permeable layer of rock, usually bedrock. So we need to get to a less permeable layer where the water stops moving and pools to have a well. If a sediment or rock layer is saturated, completely full of water, is it able to provide a steady supply of water? Well, I would say that depends. You're going to have to decide for that one. Does it rain all the time? Is it going to keep being saturated? It just depends. You could pump this dry. And if it doesn't rain, if it doesn't recharge, if the water doesn't infiltrate down into the rock through the layers again, you're not going to have any water after you pump it all out. So it's up to you to think about this question. And we'll see you in part 3 for parts 9 and 10. Thanks so much for watching. See you soon.